as a scientist, we are told what is the boiling point of water. Maybe that's what I should have started. If I ask you, I know you all mentioned, boiling point of water is 100, boiling point of water is 100. As a scientist, don't go speak like the ordinary people do. Say the boiling point of water is 100 degrees Celsius, as long as that very pressure there is 760 millimeter mercury. That is what you should say. Because as soon as that atmospheric pressure changes, you don't get the water to be boiling at 100 degrees Celsius. If the atmospheric pressure drop, you boil the water will not get to 100 degrees Celsius. The pressure that it will create in the system at that time would have been equal. Let's say at a place where we get the atmospheric pressure being 700 millimeter mercury. You don't need to heat water up to 100 degrees Celsius before you arrive at the pressure in there becoming 700. So it means that maybe around 86 degrees Celsius, around 92 degrees Celsius, the pressure that would have been created in this boiling system in an atmosphere like this, which is 700 millimeter mercury, that pressure there will also be equal to 700 millimeter mercury, and the water will boil. So water boils at 100 degrees Celsius if and only if the atmospheric pressure within the system where you are taking the experiment is this 760 millimeter mercury. So let the ordinary people, your mates, know, general science, water boils at 100 degrees Celsius. But for you, a scientist, when they say what is the boiling point of water, it's 100 degrees Celsius, even only if the atmospheric pressure at that place there is 760 millimeter mercury. Else, we'll say water, the boiling point of water varies with the atmospheric pressure. Now, I'll bring this one down. It's hot, and I'll do something to it. We'll see what will happen. So now, I'll put the balloon on top of this. I'm putting it back. We are going to see the pressure that is going to create in this. So, you see that once I dropped the water from the fire, the water has cooled down. So it is no more boiling. In other words, its temperature has come down. So the vapor pressure that was being created in the liquid, in the container here, has gone down. I'm still applying the heat very soon. So you see it. Now look at the shape of the balloon. It means that molecules of the water are now again started escaping. So when they escape, they are becoming gas. The balloon I put here is just telling me I want to trap the gas. Where's the gas coming from? It's coming from the water molecules that are moving. And assuming now to take the volume of the water, I will see that the volume of the water is what? Reducing. Because I'm converting the water molecules to gases. Now let's look at it. You see, water is creating the vapor. It's the vapor that is collecting the balloon here. And that is the pressure that's being mounted in there. Let's look at it critically. At a point, when the vapor pressure becomes equal to the condensation, in other words, at a point when the rate of evaporation becomes equal to rate of condensation, the system, the water here will be said to be, the pressure that is exerted will be said to be saturated. At that point, the balloon will not expand. Let's watch it. Watch it critically. So, now look at it. You see where it has started boiling. The shape of the balloon has become constant. That is saturation point. But if I still apply the heat, the rate of evaporation will now become or go above rate of condensation. The balloon will begin to expand again. Watch it. The balloon is going to begin to expand again. And it will expand and expand and explode. Because at that point, the energy I'm applying, almost every liquid here, or the liquid here, have now become almost like gases, and they are trying to move into the gaseous state. So then the balloon will become so big that it can no longer contain the gas, and it will have to explode. So that is science for you. So you see what science is all about. Science is based on facts. We have experimented and we see what happens. And science tries to understand nature. Without science, my brothers and sisters, we would not exist. Okay? we would have destroyed the environment and we would all be dead and gone by now. So science tries to understand nature, and that helps us to live conveniently among ourselves.